Hi, it's Miss Barnett. I'm coming at you from Quarantine 2020. What? So, today we're going to continue with logarithms. Who knew? So today we are going to be able to use the change of base formula. Change of base like ace of base. I saw a sign, but it opened up my eyes. I saw the sign. Change of base formula and solve logarithmic equations using those properties that we just learned. So the change of base formula, it's a different way to evaluate stuff. I'll show you in a sec. Well, like for example, if we have log base, I don't know, 3 of 9 is equal to x. Remember, we would get just this log base 3 of 9. And then I told you set it equal to x. And swoop-de-doop it, 3 to the power of x is equal to 9, which is 3 squared. So x would be equal to 2. But what if we get something down here like this example where if we did a swoop-de-doop equal to x, then we get 3 to the power of x is equal to 8. I can't change 8, so it has a base of 3. What do we do? Well, the answer is the change of base formula. I know you were wondering, what do we do? So the change of base formula looks like this. When you have log base b of a, I can use my calculator and do log a divided by log b. And it gives us a decimal. We're going to have to use our calculator. Calculator. And make sure we put our parentheses in properly. Make sure to use parentheses properly. All right. I'm going to cloud that up because why the hell not? All right. So this is not how we're going to solve this problem. We're just going to use the change of base formula. So that looks like we're going to do this part on top, log 8 divided by the base, it goes on the bottom, log 3, base, bottom. That sounds about right. And I just got to use a calculator and look at handy dandy. Oops. So let's do this right. So first, for this calculator, I'm going to have to do 8 and then press log and then equals, no, clear. Okay, 8 log equals, no, 8 log divided by, there we go, 3 log is equal to 1.893. And I'm rounding to 3 because I'm doing 3 decimal places. There's the 7. I want to make the 2 go up. So that is going to be 1.893. I encourage you to take a moment and pause this video as you go and try it on your own. And I know you're all doing that because you're great math students and you want to know how to do this on your own. Great. All right. So I hope you paused. Now, log base 15 over log base 4. When I do my calculator, I just figured out how to do that. So it's going to be 15 log divided by 4 log is equal to 1.953. The 4 does not make the 3 round up, so it's just going to say 1.953. 1.953. I'm going out to 3 decimal places because that's what it says right here. These are the 2 answers I have so far. All right, I'm not going to make you watch me do the calculations anymore. I'm just going to do them. So first it's going to be log, and if you were using a different kind of calculator, make sure you put these numbers in parentheses. Sorry, I didn't say that. So log of 7 divided by log of 5. Like when I had to use my phone earlier today, I had to put the parentheses in. Okay, so that would be 1.209 when I solve that one. This one is log 17 divided by log 4. The 4 is on the bottom. It's 2.044. Log 12 divided by log 3 with parentheses, because why would I forget parentheses? And that is 2.262. And last, log 21 divided by log 6, that's going to be 1.699. So we use the change of base formula when we can't write it in exponential form and get the same bases. This lets us find the answer. We can evaluate logs no matter if they work out with exponential form nicely. All right, so the next part of the lesson is we're going to solve logarithmic equations algebraically. There's steps, because why not? So let me change colors too, because we're moving on. New topic, pink. Use properties of logarithms to get a single logarithm on each side. And then we're going to solve. Either if there's only one logarithm, one logarithm in the whole equation, we're going to rewrite in exponential form and solve from there. Rewrite in exponential. Or step 2, the second part is if there's a log on both sides of the equation, we can drop the logs and just set what's inside equal to each other. So drop logs. All right, and then check your answer. We do not want to have negative numbers. We can't take the log of a negative number. So the log of a negative number cannot be calculated. Negative number cannot be calculated. So like say I had log minus x plus 3 and my answer was x is equal to -4. If I plug -4 in, -4 plus 3 is -1. That would be an extraneous solution because I can't take the log of a negative number. All right, so let's do this. So I see on this side I have 2 logarithms on this side of the equation. I'm going to use my handy dandy log rules to make sure that I can have just one log on each side of the equation. So when they're adding, of course, that means I can multiply these two things together. So it's going to be log base 2 of 2 times x minus 2 is going to be equal to 6. And I can distribute that 2 in. So that's going to be log base 2 of 2x minus 4 is equal to 6. And from here, I'm going to do the patented Mrs. Barnett swoop-de-doop method and put it in exponential form. So 2 to the power of 6 is equal to 2x minus 4. So 2 to the power of 6 is equal to 2x minus 4. And from there, I'm just evaluating. 2 to the 6th is 64. I can either use that chart or do 2 to the 6th in my calculator is equal to 2x minus 4. And now I'm just solving. Add 4 to both sides. I get 68 is equal to 2x, and I divide by 2. So when I divide by 2, I get 34. X is equal to 34. Mommy. Yes?
Those Legos are upstairs.
Oh, I don't care. Go to the bathroom.
Can I get a Lego?
No, go to bed.
I need a baby.
Go. Ask Dad. All right. So, again, now on this side, first, I'm going to get rid of this coefficient in front by making it an exponent. So I got log base 7 of x squared is equal to, and then again, these are adding, so I can multiply 27 and 3. So that's going to be log base 7 of 81 is 27 times 3. So then, because I have the logs on both sides, I can just drop the logs, and I have to know that x squared will have to equal 81. And from there, I'm just solving. So I'm going to take the square root of both. X is equal to positive 9 and negative 9. But wait, make sure you check your answers. We didn't check the last one. We'll do that right now. So when I plug in positive 9 in for this x, that one will work. Check that is an answer. But when I plug in negative 9, I cannot take the log of a negative number. So that one's extraneous, and this is my only answer. Will 34 work? If I plug in 34 right here, 34 minus 2 is still a positive 32. I can take the log of that number, so check. That one does work. All right. I encourage you, pause it. Try these next 4 problems on your own. Make sure you put parentheses around this p plus 12. But try it on your own. I'm assuming you tried it now. and you're ready to do it to make sure you didn't make any mistakes because I'm about to do it. So I have this addition sign, which means I can use the multiplication or the product property of logarithms. So log base 4 of 3 times x minus 6 is going to be equal to 3. I distribute that 3, so I get log base 4 of 3x minus 18 is equal to 3. And then, you guessed it, the patented Mrs. Barnett swoop-de-frickin-doop method. So 4 to the power of 3 is equal to, and all this in parentheses, 3x minus 18. And now I'm just solving. 4 cubed is 64. 3x minus 18. I add 18 to both sides. 64 plus 18 is 82. And then I didn't plan this out very well because 82 divided by 3 is a decimal. It is 27.3 repeating. But will it work out if I put it in? 27.3 minus 6 is still 21.3. So yeah, it does work out. There we go. All right. Log base 4 of 2 plus log base 4 of p plus 12 is equal to 3. Let's try it out. So this is, again, an addition, so it's the product property. So log base 4 of 2 times p plus 12 is equal to 3. I can distribute that p, so I get log base 4 of 2p plus 24 is equal to 3. And you guessed it, it's the patented Mrs. Barnett swoop-de-doop method. 4 to the power of 3 is equal to 2p plus 24. I'm solving it. We just did it. 4 cubed over here is still the same. It's 64. 2p plus 24. I subtract 24 from both sides. 64 minus 24 is 40, I think, and it's equal to 2p. I divide by 2. So p is going to be 20. That's positive. It's looking good. P, or 20 plus 12 is still positive, so that works out. Again, let's do it again. Why not? Okay, again, it's positive. That's the product property. So log base 6 of 9 times 4 is equal to x. 9 times 4 is 36. Can you guess what we do next? There's only one log. There's not logs on both sides. So yep, that's right. It's the swoop-de-doop. 6 to the power of x is equal to 36. 6 to the power of x is equal to 36. Can I change these so they have the same base? Let's not forget what we already know, solving exponential equations. 6 to the power of x can be 6 squared. So x has to be equal to 2. And this one is perfect. If I plug in 2, I'm not actually taking the log of that number at all. So that one works out just fine. This one, it's a minus, so that's the quotient property, so it's going to be log base 4 of 28 on, or 128 on top divided by 2 is equal to x. We can go ahead and divide 128 divided by 2. That's 64. So it's log base 4 of 64 is equal to x. What do we do? What is it? Oh, it's the swoop-de-doop method. 4 to the power of x. We're writing it in exponential form. That's what the swoop-de-doop method is, but I like swoop-de-doop. Is equal to 64. Can I rewrite 64 so it has a base of 4? I can, and I will. It's 4 to the power of 3, and x has to be equal to 3. When I plug x in, I'm not even taking the log of that. It works. We're done. I hope this helped. Go do the practice. Have a great day. Be healthy. See you later.